Metal halide lamp lifespan and replacement strategies are critical for maintaining efficient and cost-effective lighting systems. Metal halide lamps, like all light sources, degrade over time, experiencing lumen depreciation and color shift. Lumen depreciation refers to the gradual reduction in light output as the lamp ages. This means that the lamp produces less and less light as it approaches the end of its life. Color shift describes the change in the lamp's color appearance. The light may become more blue, green, or pink as the lamp ages. Understanding these degradation processes is essential for effective lamp replacement planning. The lifespan of a metal halide lamp is influenced by several factors, one being the lamp's operating conditions. Overvoltage or undervoltage can significantly shorten lamp life. A stable voltage supply is crucial. Switching frequency also plays a role. Frequent on-off cycles can stress the lamp's electrodes and reduce its lifespan. Lamp design and manufacturing quality are also significant. Higher quality lamps tend to have longer lifespans and more consistent performance. The specific type of metal halide lamp also affects its lifespan. Different metal halide technologies, such as pulse-start or ceramic metal halide, have varying rated lifespans. There are several strategies for determining when to replace metal halide lamps. One is group relamping. This involves replacing all the lamps in a system at a predetermined interval, regardless of whether they have failed. This strategy minimizes labor costs and ensures consistent light levels throughout the area. Spot relamping involves replacing lamps only when they fail. This strategy minimizes lamp costs but can increase labor costs due to frequent maintenance trips. It can also lead to uneven light levels if failed lamps are not replaced promptly. Predictive relamping involves monitoring lamp performance, such as light outputs and color, and replacing lamps when they fall below a certain threshold. This strategy aims to balance lamp costs and maintenance costs while maintaining acceptable light levels. The optimal replacement strategy depends on several factors, one being the criticality of the lighting system. In applications where consistent light levels are essential, such as operating rooms or manufacturing facilities, group relamping or predictive relamping may be the best option. In less critical applications, spot relamping may be sufficient. The cost of labor and materials is also a factor. Group relamping can reduce labor costs but increase lamp costs. Spot relamping can reduce lamp costs but increase labor costs. The specific characteristics of the lighting system, such as the number of lamps, the mounting height, and the accessibility of the lamps, can also influence the optimal replacement strategy. When replacing metal halide lamps, it's important to follow proper procedures. Always disconnect the power supply before handling any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Dispose of used lamps properly. Metal halide lamps contain mercury, which is a hazardous material. Check local regulations for proper disposal methods. When installing new lamps, ensure that they are compatible with the existing ballast. Using the wrong type of lamp can damage the ballast or create a fire hazard. Allow the lamp to warm up completely before turning it off. This helps to extend the lamp's lifespan. Keep records of lamp replacements. This information can be used to optimize the replacement strategy and track the performance of the lighting system. The National Electrical Code, or NEC, provides guidelines for the safe installation and maintenance of lighting systems. For example, NEC Article 410 covers the requirements for luminaires, lamp holders, and lamps. Specific sections address the installation of metal halide lamps and the need for proper enclosures. NEC Section 600.10 covers the requirements for electric signs and outline lighting. Metal halide lamps are often used in these applications. It is important to consult the latest edition of the NEC and any applicable local codes before installing or maintaining metal halide lighting systems. Grounding is a critical safety measure. A proper grounding can lead to electrical shock hazards. All metal parts of the lighting system should be properly grounded according to the NEC requirements. Overcurrent protection, such as fuses or circuit breakers, should be installed to protect the lighting system from short circuits and overloads. The size of the overcurrent protection device should be based on the ampacity of the wiring and the load of the lighting system. Ballasts are essential components of metal halide lighting systems. They provide the proper voltage and current to start and operate the lamp. Different types of ballasts are available, such as magnetic ballasts and electronic ballasts. Electronic ballasts are generally more efficient and provide better lamp performance. When replacing a ballast, use a compatible replacement. Using the wrong type of ballast can damage the lamp or create a fire hazard. Regularly inspect ballasts for signs of damage, such as cracks, leaks, or overheating. Replace any damaged ballast promptly. Proper wiring is essential for the safe and reliable operation of metal halide lighting systems. Use the correct wire size and type for the application. Make sure all connections are tight and secure. Protect wiring from physical damage. Follow NEC guidelines for wiring methods. Energy-efficient metal halide lamps and systems are available. These lamps use less energy to produce the same amount of light as standard metal halide lamps. They can save money on energy costs and reduce the environmental impact of lighting. Consider replacing existing metal halide lamps with energy-efficient alternatives. Control systems, such as occupancy sensors and dimming systems, can further reduce energy consumption. Occupancy sensors turn off the lights when no one is present in the area. Dimming systems allow the light levels to be adjusted to match the needs of the occupants. Properly maintained metal halide lighting systems can provide reliable and efficient lighting for many years. By understanding the factors that affect lamp lifespan and implementing effective replacement strategies, it is possible to minimize maintenance costs and maximize the performance of the lighting system. One key to long metal halide lamp life is proper burn-in. When a new metal halide lamp is first installed, it should be operated continuously for at least 12 to 24 hours without being switched off. This initial burn-in period helps to stabilize the arc tube chemistry and maximize the lamp's lifespan. During this initial period, the lamp can exhibit color variations that will stabilize. Avoid switching the lamp off during this process. This burn-in is especially important for pulsed-arc metal halide lamps. It's crucial to avoid short-cycling metal halide lamps. Short cycling refers to repeatedly switching the lamp on and off in short intervals. Each time a metal halide lamp is started, it places stress on the electrodes and shortens the lifespan. Allow the lamp to cool down completely before turning it on again. A cool down period of at least 15 minutes is generally recommended. The orientation of the lamp can also affect its lifespan. Some metal halide lamps are designed to be operated in a specific orientation, such as base up, base down, or horizontal. Operating the lamp in the wrong orientation can reduce its lifespan and affect its light output. Consult the lamp manufacturer's specifications for the proper orientation. Light loss factors should be considered when designing or maintaining a metal halide lighting system. Light loss factors account for the reduction in light output due to factors such as lamp lumen depreciation, dirt accumulation, and surface reflectance. By considering light loss factors, it's possible to ensure that the lighting system provides adequate illumination throughout its lifespan. Voltage fluctuations can also affect metal halide lamp life. A stable voltage supply is essential for optimal lamp performance. Voltage fluctuations can cause the lamp to flicker, dim, or even fail prematurely. If voltage fluctuations are a problem, consider using a voltage regulator to stabilize the voltage supply. Ambient temperature can affect metal halide lamp performance. High ambient temperatures can reduce lamp lifespan and light output. Ensure that the lamps are properly ventilated to prevent overheating. Low ambient temperatures can also affect lamp starting and performance. Some metal halide lamps require a minimum ambient temperature to start properly. One tool used in lighting design and maintenance is a light meter. Light meters measure the illuminance, which is the amount of light falling on a surface. By using a light meter, it's possible to determine whether the lighting system is providing adequate illumination. Light meters can also be used to monitor lamp lumen depreciation and identify lamps that need to be replaced. Regular cleaning of the luminaires, or light fixtures, is essential for maintaining light output. Dirt and dust can accumulate on the reflector and lens of the luminaire, reducing the amount of light that reaches the work surface. Clean the luminaires regularly to maintain optimal light output. It is important to verify the capacitor rating and condition. The capacitor is a component in the ballast circuit that helps to regulate the voltage and current to the lamp. A failing capacitor can cause the lamp to flicker, dim, or fail prematurely. Inspect the capacitor regularly and replace it if it shows signs of damage. For troubleshooting metal halide lamps, if a metal halide lamp fails to start, there could be several possible causes. One is a faulty lamp. Try replacing the lamp with a new one to see if that solves the problem. Another possible cause is a faulty ballast. Use a multimeter to test the ballast output voltage. If the ballast is not providing the correct voltage, it needs to be replaced. Loose wiring connections can also prevent the lamp from starting. Check all wiring connections to ensure that they are tight and secure. If a metal halide lamp flickers, there could be several possible causes. One is voltage fluctuations. Check the voltage supply to ensure that it is stable. Another possible cause is a faulty ballast. A failing lamp can also cause flickering. If a metal halide lamp has a color shift, this is a normal part of the lamp's aging process. As the lamp ages, the color of the light may shift towards blue, green, or pink. If the color shift is excessive, the lamp should be replaced. Some color shift is to be expected over the life of the lamp. It is important to observe the manufacturer's guidelines. For emergency lighting situations, metal halide lamps may not be the best choice. Metal halide lamps take several minutes to warm up and reach full brightness. This delay can be a problem in emergency situations where instant illumination is required. Alternative lighting technologies such as light-emitting diode or LED and fluorescent are better suited for emergency lighting applications because they provide instant on illumination.